Okay, so year 10, we've got a quadratics test coming up. I thought I'd do a little screencast here and just talk through last year's test. So go through the solutions to that. Maybe that'll help you with your preparation. Okay, that's the idea anyway. So I just want to right. Let's have a look. So how do we? This sort of goes through all the things we've looked at in quadratics, and it's been a big section. So it's time to try and tie it all together. The first thing is that we need to know how to expand. Now you expand by removing brackets. Remember, factorizing inserts, expanding removes. So this removal process, you might remember it by FOIL: first, outside, inside, last. We've got to do 4 pairs of multiplications. So x by x is x squared, x by 4 is 4x, 3 by x is 3x, 3 by 4 is 12. Now you've got to be able to expand before you can factorize. X squared plus 7x plus 12. Now we learn a lot about going back the other way, about having a quadratic like this and learning how to factorize it, coming up with two numbers that multiply to 12 and add to 7. Now you can see how this plus 4 plus 3 comes into play with the 4 and the 3, and how it all works when you unravel it. Expand a perfect square. Now this is where you can easily make mistakes. I see a lot of x squared plus 9s, and we forget about this middle term. Right, we get x squared and treat it like this. Just write it out as a x minus 3, x minus 3, and you can't really go wrong. You get 2 minus 3x's in the middle because you've got the same numbers, and minus 3 times minus 3 is 9. So we end up with x squared minus 6x plus 9, excuse me, and that minus 6x is the term that's often neglected here. A quick way, if you want to think of it this way, is you square the first term, you get the product of the two terms, which is minus 3x, and you double it, and then you square the last term. If you can remember that shortcut, then by all means. Otherwise, do it this way. Now expanding, this looks like 3x plus 2, 3x minus 2. What we end up with this, if we still go through the FOIL process, 3x times 3x is 9x squared. Look at this, minus 6x, and we're going to get a plus 6x in here. Those two terms are going to cancel each other out. Minus 6x plus 6x, they're going to wipe each other out. And then we end up with a minus 4 on the end. So we end up with just 9x squared minus 4, and you'll recognize this as what we call the difference of two squares. Now this comes up a lot in our work, difference of two squares. When we're going back the other way, we recognize the difference of two squares, recognize that 9x squared is 3x all squared, and that 4 is 2 all squared, and then we put 3x plus 2 and 3x minus 2 into our factorizing brackets. All right, so this is a really good thing to do, isn't it? Because it helps us understand factorization. Now this beast here just needs a little bit of everything, doesn't it? So we do our FOIL on the first set of brackets, right, minus 6x minus x. So I'm just running this through like this, and then plus 3. Now I need to run this x through the 5 and the minus 2x. And then I need to just collect all my like terms. 2x squared minus 2x squared. So they go. It's minus 6x plus 5x minus x minus 6x plus 5x. Oh, there's another minus x there. I beg your pardon. So it's minus, where's my eraser? Is that my eraser there? It is. So it's minus 2, minus 6x, minus x is minus 7x, so that's minus 2x. Gets rid of that one as well. Plus 3 goes in there. Okay. Go down to question 2. Now we're going to look at factorizing. Now we've just got two terms here, and we simply take out the highest common factor, 5a, and we get 2a minus 5 inside the bracket. Now in b, we've got a common factor of x minus 2. So we take it out, and 3 minus 2x is my other factor. 3 minus 2x just goes into my other factor. You'll see that come up again when we factorize non-monic quadratics. Okay, this is 4 terms. When you see 4 terms, look at grouping them. All right, just look at grouping those. So take out the common factor there of x and a common factor here of 3a. Now I'm expecting a common factor of x minus 4, which I get. I am not disappointed. X plus 3a, x plus 3a is my other one. So look for groupings. So much of what we're doing in this topic and the skills that are called on are just understanding what's required, what technique is needed. Difference of two squares, huge. Grouping. Look, here's a difference of two squares. 4x to the power of 4. That's a square. So whenever you see two terms separated by, importantly, a minus sign, then we're definitely looking at a difference of two squares. And your job is to find out what's being squared. What squares to 4x to the power of 4? Actually, it's 2x squared, isn't it? The 2 squares to 4, and the x squared squares to x to the 4. What squares to 9y squared? And as ever, pause the video, do these questions, answer them before me. You'll get so much more out of it. Now I've identified what's being squared. 2x squared plus 3y, 2x squared minus 3y are my factors. Here's another difference of two squares. All right, it's x plus 5 that's being squared, and 4 that's being squared. I like to bracket that. So x plus 5 plus 4, x plus 5 minus 4. So I get, and in this case I can put my 5 and 4 together and my 5 minus 4 together to get x plus 9x plus 1 as factors. Okay, this is non-monic, but look, always look to see if you can take out a common factor first. Is there something numerical or otherwise that goes into everything? Well, there is. In this case, it's 3, and that makes life so much easier because now I've got a monic quadratic here, so I can factorize that simply with multiplies to 4 and adds to 5, multiplies to 4 and adds to 5. That's 4 and 1, is it not? Just highlight what I did there, looking for two numbers that multiplied to 4 and added to 5, and I came up with those two numbers there, 4 and 1. I'm going quickly, but you'll understand why. I want to get through the paper and I don't want to take up too much of your time. You can always times 2 the speed of this as well. If you understand, you don't need so much explanation. Look at these. These are my monic polynomials. I love these. Monic, I keep saying polynomials, quadratics. Now, multiplies to minus 1, adds to 4. Oh, this says by completing the square. It's told me the method I've got to use. So don't worry about that. Don't worry about trying to find these. It's not going to factorize. I'm looking for my little eraser. It's up there somewhere. All right, get rid of that. All right, so this is by completing this, factorize by completing the square. All right, so we get our x squared plus 4x. We get our minus 1 out the way, remember? We'll do the same over here. So just to highlight the process, I'll do both at once. Push it out the way because what I want to do is I want to put in the number here that completes the square. So remember, this number here is the square of half of in this case, the 4. Square of half of 4, square of 2 is 4. Square of half of that, you got it, is plus 9. But it's not an equation. All right, so all I've done so far is I've added 4 to this expression. I've got to take it away again. I've got to take it away. Righto, so I've done that. Now I go back to what I've got. I've got a first three terms is a perfect square. I made it so. And it's x plus 2. The first three terms over here is a perfect square, and it's x minus 3. This number here being half that one. Righto, minus 1 minus 4 is minus 5. Minus 5 minus 9 is minus 14. So I'm doing both at the same time. Now, I've got a difference. I'm factorizing. So I need to know what's being squared over here. This is where the square root of 5 comes in. Okay, I've got my x minus 3 squared. That's easy. But it's the square root of 14 that's being squared there. So now I'm ready to factorize by x plus 2 plus the square root of 5, x plus 2 minus the square root of 5 are my factors. See how it works over here. Say after, or say before me, say with me, x minus 3 plus the square root of 14, x minus 3 minus the square root of 14. Hopefully you're getting the hang of that now. Go down, simplify the following expressions. How do we do that? I'm just going to do this first one here maybe. Alright, I'm going to firstly simplify the following. So it doesn't say it here. By factorizing first, you always factorize. Once you factorize, you'll see common factors everywhere and you'll be able to simplify. Alright, so x squared minus 9, there's one of my little difference of two squares, x plus 3, x minus 3, because the 3 is being squared to get that. Okay, x squared plus x minus 6, two numbers that multiply to this minus 6 and add to 1. What are they? Minus 3 or plus 3 and minus 2. Righto, go over this side, difference of two squares again. X plus 2, x minus 2. What's this one here? Multiplies to 12, adds to minus 7. Alright, that's going to be minus 4 and minus 3, is it not? Minus 4, minus 3. Get out the red pen. Plus 3, plus 3. Take out, just wipe out all the pairs of common factors. One top, one bottom. One top, one bottom. Alright, I'm now left with x plus 2 over here over x minus 4. And I have simplified. Now over this side, I would do the same, except I would, first step is to just turn this into a times and reciprocate the second fraction. Alright, this is good. X squared minus 3x minus 10. Then just go ahead and do what we did here and factorize each of these. And if you can do that by pausing the video and then getting direct feedback, that'd be great. Okay, the first one here multiplies to 2 and adds to 3. That's 2 and 1. I've got an x plus 1 there, that's easy. This one here multiplies to 25 and adds to minus 10. That's minus 5 and minus 5. Multiplies to 10, well minus 10, and adds to minus 3. That's minus 5. Be careful with your signs, and plus 2. So x plus 1 and x plus 1 disappear. X plus 2 and x plus 2 disappear. X minus 5 and x minus 5 disappear. Beautiful. All I'm left with is an x minus 5 on top. I've just got 1 underneath, so there's my answer. Question 4. All done. Question 5 is solve. Solve. I love solves. Equations now. And what we're going to do is we're going to look for two numbers that multiply. So we're going to always look to solve our quadratic equations. Quadratic because there's a 2 there. It's squared. Remember, two solutions. We're looking to solve them. Solve by factorization. By factorization. If I can't factorize, I'll use the quadratic formula, or I'll solve by completing the square. But factorize if you can. Multiplies to, alright, but solve each of the following equations by factorization, but by first making the quadratic equal to 0. This is really important. You can see in C, we don't have that, so we're going to have to move everything to one side. We'll come to that in a second. By factorization and making the equation equal to 0. Alright, multiplies to 33. Once we've got it in this equals 0 state, and it's this 3-term quadratic, we're looking for two numbers that multiply to minus 33 and add to minus 8. So 11 and 3 come to mind. 11 and 3, one of them being negative, that'd be the minus 11. So this factorizes to x minus 11, x plus 3. Okay, and we know that once we factorize it like this, that my solutions are x equals 11 or x equals minus 3. Remember, the sign here is going to be the opposite of that one when we're solving. X equals minus 11 or x equals minus 3. Right, the logic there, we make each of these equal to 0. Right, and when you solve that, when you solve x minus 11 equals 0, you get x equals 11. Adding 11 to both sides or moving the 11 across. And likewise with this, x plus 3 equals 0, you get x equals minus 3. Go to B, two numbers that multiply to 9 and add to minus 6. Yes, we've got an equals 0. We've done that check. Perfect. Let's look to factorize. Multiplies to 9, adds to minus 6. That's minus 3 and minus 3. Now what we get here is actually x equals 3. We only get one solution. Right? If we solve both these, we get the same solution of 3. So x equals 3 is our only solution. Go down to C now. It's what I was talking about before. This is not equal 0, so make it equal to 0. 2x squared, so bring the 10x over, to the left. Always take the terms across to the x squared or the positive x squared side. Minus 28 over here. Now the right hand side is empty, so it's equal to 0, so that's good. Right, now divide through by 2, because they're all even. X squared minus 5x minus 14 equals 0. Now look for two numbers that multiply to minus 14 and add to minus 5, and that is minus 7 and 2. So we factorize to x minus 7, x plus 2 equals 0. So we get x equals 7 or x equals minus 2. Opposite sign, opposite sign. Okay, look at this one here. Look, it's equals 0, that's good. Multiplies to minus 3, adds to minus 5. Can you think of a number that does both of those things? I think you'll find that there are no two numbers that multiply to minus 3 and add to minus 5, because to multiply to minus 3 you need 3 and 1. How are you going to get 5 to add out of 3 and 1? You're not going to get there. So here, when you can't factorize, right, so this is a really important point, when you can't factorize, use the quadratic formula. That's my tip. Okay, you can if you wish use completing the square method, but especially with an odd odd number here, it's going to be hard because you're going to have to, halve it and square it. It's messy. Use the quadratic formula. The quadratic formula is minus b plus or minus b squared minus 4ac over 2a. Right, now this value of b is minus 5. So I actually have minus 5, so that's a positive 5. Is b squared is 25, because anything squared is positive. Minus 4 times a, which is 1, times c, which is minus 3. Put that all over 2a, and 2a is equal to 2. So we get 5 plus or minus square root of 25 minus, now we get 4 times 1 is 4 times minus 3 is minus 12. So it's 25 minus minus 12 all over 2. Right, to tidy that up, it's 5 plus or minus 25 plus 12, which is 37, all over 2. And that's how you leave your answer. Leave it in exact form. You can put all that in your calculator if you like, but leaving it as a third is perfect. Okay, so that's all the questions on in just a purely algebraic representation. We've got a couple of problem questions, sort of applications of quadratics. So I'll have a quick look at these as well. A rectangular billboard is 6 meters longer than it is wide. So I've got to draw this thing. It's always good to draw a diagram. Here's my billboard. It's 6 meters longer than it is wide. So I'm going to have to make the width x so that I can make the length x plus 6 meters longer than it is wide. Now I've put some algebra in, and I know the area is equal to 72. And I can tell that the area of a rectangle is x by x plus 6, or length times width. So now, before I know it, I've got myself a quadratic. I'll bring that 72 across this side. It's minus 72. I've got a quadratic equation. I've got equals 0 here. I'm now looking for two numbers that multiply to minus 72 and add to 6. And those two numbers are 12 and minus 6. So I just solve this as x plus 12, x minus 6, and therefore x is equal to minus 12, or x is equal to 6. Now x can't be equal to minus 12 because it's a length. So x is equal to 6, and make sure we answer the question, find its dimensions. So therefore, width equals 6, and length equals 12 meters. And that answers my question. Okay, let's go down. We've got a little Pythagoras question. We would create or write Pythagoras' theorem here, which is x squared plus x plus 2 squared is equal to 10 squared, and then we'd simplify it, x squared plus 4x, don't forget that 1 plus 4 equals 100, 2x squared plus 4x, bring the 100 over, minus 96 equals 0, So we divide through by 2 and we get this. I remember this one from the exercises. It's 8 and 6 with the minus 6 being negative. So therefore we get x plus 8, x minus 6 is our factors, and therefore x is equal to minus 8 or 6. X can't be equal to minus 8, so x is equal to 6, and we've solved. Just make sure we're answering the question. And question 8 is the last one. When a number is subtracted from its square, the result is 132. When a number is subtracted from its square, the result is 132. So we just let the number, when a number, let that be x, is subtracted from its square. So it's, if the number is x, then its square is x squared. And we'd solve this by bringing this 132 across, and then we'd factorize it. 11 12 is 132. So if we make the 12 negative and the 11 positive, we'll get minus 1 as a sum. So therefore x will equal 12 or minus 11, and both those solutions work for the number. Okay, so that finishes a little rushed version of the work solutions there. I have one more thing to discuss. Actually, I'll do that in class, so I'll leave that there, and hopefully you'll have a chance to get through this before the test paper tomorrow, because I think that will certainly help you with that. Okay, see you soon.